Hey guys, I'm doing another code review. This is for the Fountain of Objects. This is a person submitted this code in the challenge help channel on Discord, and uh, part of it is that I could tell from their comments and in the code and on in Discord that they were having a hard time of it. I think I saw they said something like this is their third attempt at this, and they've kind of struggled each time. I will say that there were a bunch of people who jumped in and helped, and I appreciate that. The comments I saw made it look like they felt like they, had made some progress and were in a happier state. And this is the code from like before, so this is like the problematic code, and they were able to work through it. So maybe I should not even bother with this, just because they've already come up with a solution for what they were doing. And now I'm maybe throwing additional ideas into the mix. And I don't like that may just be more confusing, but there is something in this that I feel like is broadly useful that I feel like it's worth taking some time to like look over the code, review it, and kind of discuss like my thinking on it. And again, I say this a bunch with these reviews is like it's very clear that so I mean this person, let's see, like a lot of work's been put into this. Um, like this is probably hours upon hours of deep thinking about this problem, and I mean this we end up with like a couple hundred lines of code here. Where are we at? So this is the end right here. Don't worry about the stuff down here. That's my own stuff that I was doing earlier. This is my sandbox project, and I just took the code and dropped it in here. But um, the thing that so like I said, there is a lot of really good that could be said about this, and like I say, it's very clear this person's put in a lot of time to try to like make this work, and they're just trying to figure out how do I make this code better? How do I take the next step? Because like this is getting complicated, and I think like the stuff that's here on the screen, I think people would look at and say, yeah, this is like this doesn't feel right anymore. So what should we do? Does it really have to be like this? And like there's a comment in here of like look if I just like I know like the pit is at a hard coded like it's at like 3.2, it's in a known location, and why couldn't I just check that? They had at one point had anyway I like it's I totally get where the person's coming from, and for what it's worth, like the things, and this is okay, I'll start talking as though I'm talking to the person who wrote it, even though like I said I don't. The person who wrote this may not end up viewing this because, like I said, they got themselves unstuck with some help from people on in Discord. But I so again, I'll talk to you as if whoever you the viewer is the person. Is this your code? I so I will say like if you're in this state, the C sharp isn't the issue. Um, And I wouldn't even say like the software design is the issue. The challenge here is an algorithm challenge, right? Like this is like some of the stuff of like, well, how do I like efficiently, not I mean maybe in terms of performance, but just in terms of like building code, how do I efficiently like detect if I don't know exactly if I don't know where the player if well I know where the players, but if I don't know exactly where the pits are, so I can't just hard code it. Um, how would I how do I even like figure out if there's a pit by a player if I all I have is a let me jump down here. At a high level, the data structure here is that like the game has a grid which essentially just has a 2D array of rooms. So how do I like given where the player is at and I've got this 2D array of rooms, how do I figure out if one of the nearby rooms is a pit? And again, like that's not a C sharp issue. The C sharp in here is great. It's not a software design issue. I think the design here is solid. I think the issue is algorithms, and this is one of those things that once you've solved a particular algorithmic problem, it tends, especially if you have to like struggle for it, it tends to stick with you. So the next time you're doing something like it, you'll be like, oh yeah, I did something like this. It gets easier, but it is tricky. I see the same thing like just even with the tic tac toe challenge, where it's like, how do I find out if there's three in a row? Like you like that sounds so easy. And for a human to look at a little 3x3 grid in tic-tac-toe and say, oh yeah, you got three in a row. Do diagonals count? Yeah, diagonals count. Yeah, okay, you got three in a row. Like it's really easy for humans to do that, but to teach the computer how to do this algorithmic stuff is surprisingly tricky. So don't panic. Things are gonna be okay. You're in good shape. Like I say, you're learning the C sharp. It's just this game, the Fountain of Objects, presents some algorithmic challenges. And you know what? Unfortunately or fortunately, like it doesn't give you a ton of guidance on it. It kind of leaves you to your own devices to figure it out. So that's really what we're talking about here. But again, the main takeaway that I should have led with, I'm just not very good at YouTube optimization, is I think the real lesson to be learned here is if you're struggling, especially if you're looking at code like this and saying, man, this is like, it's just getting, and like kind of this comment of like, do I need to like add nested if statement for each of these? Like, do I need to come in here and like, if it's this, then come in here and like put like, if it's something else, like how bad does this need to get? So I think that's what they're worried about here. Do I need to make sure that the player X and player Y aren't bigger than the grid side, like off the grid? So the main lesson I think is sometimes when you have these complexities, it's useful to try and back up a little bit and figure out like what would be a tool, like a method that could, if it existed, would simplify my life, and then go build that. So as an example, what I might consider is something like this, because I like this right here, player. I think this logic, and I like this is I think the person's complaint is it's just there's a lot of weird, like this is hard to reason about, it's hard to think about. So how do we address this? Well, the one thing I might say is, suppose we had a method. I'm gonna like jump over here to grid, and I'm gonna do this. I'm gonna say public bool is inside grid int x int y, and then so if so the question now is like, okay, so can I like I've found a, like if I had this as a building block, if this just existed, would it be helpful? And I think the answer to this will be yes. So now I have to write it, but now I don't have to solve the whole problem like in the context of like all these other if statements. What I can do is I can just zoom in and say all I have to solve when I'm writing this method is answer the question, is it inside the grid? So if x is less than 0, return false. It's not. Like if it's negative, we're off the grid. If x is greater than grid size, and actually I'm gonna say if it's greater than or equal to grid size, return false, because if like because of zero based indexing, like if the grid size is 4, then 0, 1, 2, and 3 are allowed. Oh, great! It added curly braces, just what I needed. So we if it is the grid size, we've gotten too big. And then we do the same thing for y. Okay. So and like so I mean I just wrote that method, but I have written this particular method. I don't think I'm exaggerating to say I've probably written this exact method, at least the philosophical view of this method, at least 100 times. This is second nature to me because I've done it so much. At one point, I probably either saw somebody write it this way and thought, "Oh, I like that," or I had a struggle for a long time to like think through, like, well, but what, like and like a time where like I accidentally did this again, uh, or a time where like I accidentally did that, or a time where like there's just so many ways that this could you could get it wrong. So okay, so suppose now I have this method is inside grid. Now I can use that in other places, and maybe that helps. So like it's this kind of thing here. A sec. Okay. So like I think the thing here so this right here, if grid dot rooms array, and I actually don't think that this math dot absolute value is like I think that this will ensure that if we went to -1, we don't like actually index into this as a -1, which will blow up. Instead, it'll index into it as +1. But now we're asking about the wrong room. So I think like what we really want here is not this math dot absolute value. So I'm going to just take that out and basically do this. So int row equals, I'm going to call it target. Int target x equals player dot x. Int target y equals player dot, let's see, x minus 1, y plus 1. And now we could say if grid dot is inside grid, target x, target y, and target x, target y. So now we have this a tool that we could use to check this stuff, right? Um, but I think the interesting thing about this is that right is this code right here. I think looks like it's trying to say so if it's greater than 0, we can if it's greater than 0, we're allowed to like go down one lower. And this, so player dot x is less than or equal to grid size minus 1. Like this is just is the player is a player on the grid. And theoretically, like given that we are going like our code here goes to the left one, it goes, x minus 1. We technically don't need this check. But before I get into that, like, and so this is like, and player dot y is greater than 0. Like this, I think could be like I think there's some complexity here with just trying to figure out like, am I allowed to even do this check? And I think one of the interesting things that you might realize about this is we can just figure out like where it is. It may have fallen off the board. It may be too big or too small in either X or Y, but this code right here will tell us that. Right? So at this point, I don't like yeah, we're trying to see if it's going to be an issue, but let's just always figure out what that is, because that math is from a performance standpoint, that math is not like that's going to it doesn't get much more efficient than a subtraction. There's a little bit more here, but like this is pretty efficient code. So I think we could do that. And we could do that for all of these, and then it just like it gets it's interesting that like so I feel like this is not exactly sure why, and maybe that's the issue here. But I guess my point is we ought to be able to do the exact same thing for all of these. And it helps to have this is inside grid. Now, anyway, so like I said, sometimes it's just a matter of like if we can build the right tools, it will simplify our code a lot. And in this case, I don't really feel like it's gotten a whole lot simpler, but I do think if you have once you have this method, a lot of this other like because I don't have to think every time about like do I subtract one plus one like I'll just do the math to figure out the intended square, and then I'll just say, well, is whatever I came up with the same things? Like I don't need different logic in here. Like ultimately, I can just say if grid dot is inside grid player dot x plus one player dot y plus one, and like it could be the same thing here. Okay, so I don't know that this is making things simpler, but like the other thing I'll say is like there's probably still additional methods we could write that might be just these little teeny pieces that could be helpful. So for example, and I'm gonna what I'll do here is I like it to I'm gonna okay, what I'll do is this public. So this is complicated because okay, I'm getting ahead of myself here. But the let me walk you through my thinking as best as I can. I can think faster than I can type. I'm thinking it would be really nice if I just had a method that would just tell me all the squares that are adjacent to another square. And I'm willing to let that be off the board, right? So if I say yeah, so let me do this. Um, Forget the type for a second. Pretend there's something useful there, right? List all adjacent um, squares. And then we give it int x, int y. So, given this, we're just going to return all of the adjacent squares. Now, I do want this to be an array. I'll say one other thing, and that is that in the book at this point we haven't learned about lists, but it's it like that was actually partly for like the storyline, like the storytelling parts. Like I loved the idea of like once you've repaired the fountain of objects, now like all these like objects are starting to grow again because the fountain's been restored. I like that just as like a storyline point. And so like to have like a chapter that just covers some of these really basic useful types, I like that, and I think it's a good place to say. By the way, the base class library has a bunch of types you're going to find useful. You have the knowledge now to start using them, so go for it. Like it felt like the right point in the book. However, lists are one of those things that I've had some people tell me you should introduce lists when you introduce arrays. You should introduce lists instead of introducing arrays. I didn't really want to do that without introducing generics. And I also think that like lists use arrays. I think it's useful to deal with the more primitive, like more fundamental type of arrays instead of lists for a bit. But I wish that I had just like introduced lists once you do learn about generics, specifically so that you have it here. I'm gonna so I actually think a list would be a better choice here than an array, but I'm gonna use an array just because we don't technically have access to that yet. That's still coming. But what I need is to like list x and y coordinates, and so I need some way to do that, and a tuple does that. So like I could do this. A lot of people like a complex type like that is kind of scary. So like what I could do is just I'm gonna make a record I'm going to call it a coordinate. All right, so I'm going to just define this type. Um, so like I came over here to solve this problem because I think it might be useful. I don't actually know that it's going to be useful, but I feel like if I had this as a tool, so I'm kind of preemptively creating it. No, like just because my brain is struggling to grasp all of the intricacies of what we need to do elsewhere. That I feel like, well, if only I had this tool, and I don't know that it's going to help. I just think it will. And I as like I have worked on this particular challenge enough times to know that like this is going to be a useful method, and I've written enough code in general to have a pretty good idea of like I'm dealing with 2D stuff. Like I usually end up writing something like this. So like I have a lot of experience that helps me know that this is right. Um, know that this will like I'm very very confident that this is going to end up being quite useful. But it's I think it's still fair to say that in the real world, there's a lot of times problems where it's like I don't there's like it's my brain is getting overwhelmed with the complexity of the problem I'm doing, and I don't know that this thing would help, but it will a it's a smaller problem than the big problem that I think I can wrap my mind around. And B, I think it will be useful. And even if it's not, at least it gives my brain a chance to kind of mentally explore the complexities of what I'm doing here with some constraints. Like it isn't the whole problem. I'm not trying to look at the sun. I'm trying to just look at a bright flashlight instead. So I'm not going to get blinded by it. It may be that the flashlight wasn't useful, and I really do need to go back to figuring out how to deal with the the bright light of the sun. Maybe that's not a good analogy here, but here we are. So so again, in terms of like guidance for people who are kind of working through this and maybe struggling, I think it's very reasonable to say I'm having a hard time with it. What is a piece of this I'm more likely to be able to solve, like that I think could help, because even if it doesn't help, just having being able to think about a simpler problem or a small piece of the problem is a useful thing to do. Like that, even if it ends up not being helpful, just that thought process is still useful. So as I said, I'm like I am very very confident this is going to end up being useful. But even if I weren't so confident, this is still a useful thing to do. So I go from I have this big problem. It's hard to wrap my mind around. What if I build this other method to? But I don't want to make it. I don't really want to use tuples. So I stop working on that problem and jump over here and work on this problem. Um, so I'm kind of jumping around a little bit, finding little problems that I feel like are solvable that can then roll up into the bigger problems. So, and this is a one-liner, like this is pretty straightforward. That's why I love records. In the olden days, you would have had to do public class coordinate, public. In the super olden days, you'd have to like public int x. We've had properties since the beginning. Get return x, private int duplicate that for y. It's not worth it, but then add a constructor. So like it was a whole bunch of stuff. Records are really nice for these really small, just composite data types. Like I just need to combine a few things. So as much as I like tuples, I often once I records became available, I tend to like the strongly tied nature of it. I get better names. So anyway, so now I'm going to just upgrade this to using that coordinate class. And now I have to solve, now I'm back to this problem. And now I have to solve this problem. Again, I don't have to solve every imaginable problem that we were trying to solve before. I just have to figure out, well, what's a way that I could list dollar adjacent squares? Well, I'm, it's reasonable. I said this before, like it's reasonable for us to just assume that a coordinate, like we're not going to worry right now about whether a coordinate is in the grid or not. we can deal with that in a second. So again, simplify it. But in this case, all I have, like, there's one, like, 8 coordinates, and I can just do this new coordinate 8, coordinate, and then return adjacent. Obviously I'm not done yet, but adjacent at index 0 equals new coordinate. And now I just have to, like, remember, like, all the combinations. I get the combinations right. So x minus 1, x 0, x plus 1. And this one I don't need, that's not adjacent. And I gotta update my indices. And that's it. This suggesting, I'm wondering if it's going to suggest I write it using the collection initializer. Yep. And I actually like this better. However, I don't like what it did with my white space. And if we're doing that, like, so now we're in cleanup mode. I don't need to, like, store this in a variable. I can just say, oh, yeah, I actually will do it. Return that. So I don't need this down here. And I don't have to do any of this cleanup, but now if I'm doing that, I can just use an expression body. Okay. There's a version. So this just returns them all. And if x were at 0, 0, then all of these where x minus 1, these are all too far to the left, like they're off the left edge of the screen. All these that are y minus 1, there's 1, 2, 3 of them. Well, we got some duplicates. There's like 5 squares that are off the board. And, you know, like, that's not great, but, like, hey, at least I now have a tool that just tells me all of the adjacent squares, so I don't have to, like, think about that. And now what I ultimately what I want is the ability to give me all the adjacent squares that are also in the grid, like filter out the ones that aren't in the grid. I'll just mention this, that if I had the full set of tools, I would be using LINQ, and there's a whole chapter on LINQ query expressions late in is in part 3. Like, that would be a really useful tool here, but we don't need it. In fact, there's nothing in LINQ that you can't do with if statements and loops. But so if I have this method, like, what I could do, sorry, there's a thing that I could do with LINQ that would combine these. Like, what I could do, if I had a list and I had links that link, then I could just say, basically create this and then say something like dot where. Yeah, I wondered about that. New coordinate. I specify the type. Now I can say dot where is inside grid. And then there. This is, again, I'm just using all the tools here. Like, there are some ways to do that, but I'm not going to worry about that right now. Like, it's so I'm going to back this up to where we were and say, like, it's totally fine that our expectations when we call this is they might be off the grid. We'll deal with that. So now I can come back up here to this code that was starting to feel unwieldy and do something like this. For each coordinate in board dot grid dot list all adjacent squares. Oh, player.x, player.y. Right, so when we get in here, we'll have all 8 squares around the player, while knowing that like some of those might be off the board. So what we'll do here is we'll say if grid.is inside grid, target.x, target.y, if grid.rooms array target x, target y, dot room type is a pit. Sorry, target dot console.write line pit nearby. Now, I want to clean that code up a little bit. What I will say is we've lost this information, and it wouldn't be easy to recover that. Like what we've got here, it'd be a little hard to do that, to like retain this information about like x minus y plus. A couple of things to say about that. One of them is we're actually not supposed to know. We're not supposed to know which direction the pit is in. So technically, we've lost it, but we're actually not, the user's not supposed to see that. They're just supposed to know that it's nearby. You know what? I'm having a, I have a, given how this code is, I think it's looking in all 8 directions. But I will say that I'm suddenly worried that this is only supposed to check 4 directions. But what I will say is, if I change my mind about that, I would just have to come in here and just like, I can just change a couple of lines of code in here. So if I am only supposed to look in 4 directions, I can. I think it is supposed to be 8 directions. I'm not gonna pause and go read the book to find out. We'll just pretend. We'll assume that it is supposed to be this. Anyway, but if I really felt the need to do that, what I might do is, like right now I've kind of built this coordinate as a type that I think could be broadly usable. Like I could imagine a coordinate that's useful everywhere, but like I could make it a little more like narrow, like it's for this very specific thing. And now I could come in here and say like x minus y minus, right? Like I could just add this information in here, x minus y. Like so I could add that information here, and then up in here, now I can do plus target dot description. So if I really like that, like when we come up with the coordinate, we know the direction it's in, and we could do that. So if we wanted to, like that's an option. I like having that coordinate class be broadly useful, and sticking the description on there kind of feels like a very narrow case. And I said it'd be hard to come up with like descriptive text on the fly, but like you could do something like if target.x is less than player.x, then like we know that like this is the x minus part, right? So like we could come up with it, but I'm not going to worry about that. The other thing I'll say is this is a lot of like indented stuff, and like I said, with link, and like I could definitely rework this to do something else. Like I could put a dot where, but that's using link, so I'm not going to do that. But what I will do is flip this around. So if it's not inside of the grid, continue. So if it's off the grid, we'll stop here. And now I can unindent this. And I also, so I noticed in the code, like this person's style is to have the curly braces anyway, even though in some cases it's all on the same line. That's is a personal preference, right? But I'll just leave out the curly braces and move it to the next line. In this case, move it to the next line. So, um, I think the thing that I'd say here at this point is I think we've accounted for all of this, but I think that theoretically that code it accounts for because we've this list all adjacent squares. We look in every direction, all 8 directions, and that basically we're accounting for all of those checks here. So I think as far as I can tell, like I said, without there's a lot of complexity here. I might be getting that wrong, um, but I think it accounts for all of this code. And so now at this point, like I think this text here can become like the text. And so like I think we're good with this comment. Do I need a nested if statement for each if statement here to make sure player X and player Y aren't bigger than the grid size? This is insane. Again, I feel for you. I really do. I've been there. Um, like I said, it gets easier, so don't worry. It's easier. But so do I need a nested to make sure player X and player Y aren't bigger than the grid size? And like I said, even if we gave this like negative 4,000 and positive 1 billion, we don't care. It's fine. Like, yes, this is going to give us values that are not on the board, but this method right here will save us. So we're good. Now I don't, this comment here, this will not probably report on 2, 3, for some reason, if you're on 3, 3. So again, like I'm going to back up just a bit here. I suspect that like some of this stuff just feels like I don't understand why we're like we do these checks, but I don't understand. Like I feel like there's like I feel like the some of the stuff with like the math.abs, how it's like checking like the wrong way might be getting in the way. Like I said, if we go if we ended up attempting to check at -1, I'm worried that that will then like that should have been off the board. We should have said no, it's not a pit. But now we're checking as though we're looking at +1 because it's absolute value. It's like I wonder if that particular comment was basically just some logic bug, which are those are I mean they're again, it's not about the C# language, it's about the algorithmic complexity and it's hard. Like I said, it's but there's only one way to get better at it, and that is to allow your mind to just grapple with these problems for a while, and it gets easier over time. Like you'll eventually start to solve some of these things. In like if in some cases you might start to say, well, I this particular like what if I just don't add this feature to the game? I'm not my programming skills are not quite there yet. So what if we skip this feature for the first release? What if we do this later or in the you know super cool game 2? So I don't know for sure what this comment's referring to, but I think we've accounted for it. That's not to say that we don't have a bug in this code or this code, but again, if suppose there is a bug, I think it's a lot easier here to go to this description now. I think it's a lot easier to reason about this method whose only purpose is to come up with a list of all the adjacent squares and like and again, like I've used the white space here to help me understand what I've accounted for and what I haven't. I've had times where I've done something like this. Because that helps me like visualize like, okay, I got X -1. Oh, well, okay. Now that I've arranged it this way, I would prefer for these to all be this to be the X -1s instead of this way. Like I transpose it, flip it around. So I get X -1 here and I get the Y -1 here. But anyway, So like I've done a bunch of stuff here to try and make it so that if there is a bug, if I do need to revisit it, like it's easy for me to like reason about it. And same with this here. Like I'm pretty sure I didn't make a mistake in here. But if I did, like now I can like at least I can just zoom in and say, is inside grid actually working correctly? And it's easy for me to just solve this one narrow problem instead of the code that we had, which was um, starting to get kind of complicated. So, and I think like all of these comments here, like I said, some of this was like absolute value has to be used here because otherwise you can go negative and crash. Again, like I said, that's true. If you go negative, it will crash. But that like we are accounting for that now with this is inside grid. So we don't get down to here unless we know we're on the grid. So by the time we get around to this, we know we're within the grid. So, like I said, I without having read every single bit of this, I think we're covered on that. So, I'm gonna delete it. I want to use the absolute value, but I don't get how to do this. For example, math.abs player.x minus. So, and this is like how this part here, like this, I read this earlier and I thought, oh, because at one point they had a one-dimensional array, and like I think if you came down here, not to grid, well, sure, where's grid? So I think if you said, look, we're gonna what we've done here, and I've kind of made a mess of this. I don't well, these are maybe okay. This method could also be a method in coordinate. So we could put it there instead. Well, like this right here. So yeah, um, a possibility that we could have done here is we could have said make this a one-dimensional array, and like so people will sometimes do that, and then they'll oops, I, I have a problem. I don't know where my comma key is if I'm just like reaching out and poking at it because you can't see it, but basically all the letters have rubbed off on my keyboard. So I just pushed 4 different keys to find the comma key. If I'm typing, it's just muscle memory. So yeah, if like this is convenient because you can just say, well, what about at 2 comma 1? And it just finds it. The alternative would be, I'm going to call it like a sparse matrix. Like if you have like a grid where like most of the data is 0 or some like obvious known value, um, there's no point using up all the memory to store, in this case, it's a 4x4, so 16 room objects. You could just say, well, if I don't have data, then pretend it's an empty room. Like assume it's an empty room, and and any interesting room I'll put in this array, but then I'll also include their coordinates. So in that case, the room becomes like the room itself knows what location it's at. So then, like if you have the pit, the fountain, the entrance, it'd just be a sparse array, and you just say, well, here, like so now this right here could just contain 3 values, not 16, but 3: the entrance, the the pit, and the fountain. And like that approach I think is viable here. Most of the rooms are empty. I think it works. Like I said, you then just have to, the rooms themselves have to have a coordinate, which again you could just use this thing here. um, that works. What I that works if it's sparse, like if most of the data isn't there, if almost all of it is supposed to be there, then you need it. Or then that's less efficient because the like right now, if you're saying, well, where are the pits, I have to iterate through every room and then check their coordinates, and it's like there's room for us to make a mistake. Like I have 2 rooms at 2 comma 2, and that's probably not what we're looking for. It's like we want to account for that. There's a lot of complexities with this like sparse array approach, but that definitely works. I think if it so, and I think somebody either in the Discord or here said something about, I got told that I shouldn't use a one-dimensional array. I should use a 2-dimensional array for these reasons. Um, if you're doing it as a sparse matrix where it only contains like the three interesting rooms, I think you can make that work. And then you would use that absolute value stuff to be like, well, how far away am I from this room? Am I within one? If so, like I'm adjacent to the room. But what I often see people do is I have it's a 4x4 thing, so I'm going to, make this not here, but like I'm gonna make a room array that has 16 elements and fill them all in. And like that also works. In fact, the last time I did performance profiling, um, that was more efficient than a 2D array. But the catch is that then in order, if you want to say, well, what's at 2, 2, you have to do a bunch of math to figure out, well, that's like at slot, let's say index 11. Like I have to like do this math to like figure out like, well, what if it's at 2, 2, what index is that? And you have to, it's complicated. So if you're doing the sparse matrix thing, that works. But otherwise, I like the 2D room thing. And anyway, so now, like I said, this stuff here I think was about that. Like, how do I find this? I think that we've covered it here. Even though I think that there are like you could have handled this other ways, and that's fair. So, okay. So a very large chunk of that code just becomes this. And like another thing I like about this is like I can do some extra stuff here. Like I know that I need to like detect other things. So like I could do something like this, and then I could do if room type equals, I don't, there's nothing else here that needs stuff, but like I can, so for example, eventually we need to like check it for if there's an Amarok in it or a Maelstrom. If there's a monster in there, so if room dot contains room dot monsters dot, oh, does an array have contains, or is that, I think arrays have it has a contains method. Anyway, so like it's like this kind of thing. Like I can also like, well, I want to do something else if there's a monster in there. I want to do like for whatever it is, there's we can build on this. So I don't have to like copy and paste that entire chunk of like 50 lines of if statements. And if I like this like list all adjacent squares, that's a method I could call in other contexts as well. Saying this is inside grid, like that could be useful. In fact, another thing you could do here is instead of having this be public, we could make this private. And then we could make public room, get room at int x int y. So we use a 2D array, but we don't expose it. And now we could say if is inside grid x comma y, return null, except for that's not. If not is inside grid, return null. Or we could do something like this: return new room. Just have a, so let's do new room type dot. So like this doesn't have like, we could do something like this where it's like off map. It's like we could return a room. Oops. I'm gonna undo this, but the point is like I could like return a room that's like, it's kind of like the is it called Bedrock in the Minecraft world, where you get to the bottom and you get these blocks that are like theoretically impossible to destroy, but then people have all these hacks to get past them anyway. whatever it is. Like it's like, hey, well, you like this is a room, but it's off the map. So now you using this instead of this. If somebody does pass in the a weird coordinate, you just say, look, I'm gonna give you a room, but it's like this phantom room that is off the map. So you could do that. Like there's a lot of things you could do here. But let's back up. All right. So yeah, like I said, this simplifies some things, and it also now gives you some smarter tools for the next challenge. Sometimes though, you don't know to build these until you start getting to that point where you're like, man, I know I already basically wrote this code. How can but I want to reuse it, but I don't want to copy and paste 50 lines of code and now have 100 lines of code that's almost identical. How much of this could I move into a method so I can reuse it? Sometimes it's you make these little helpful tools ahead of time because you're struggling to understand how to solve the big problem. And by solving little parts of it, it allows you to have tools that make it easier to start rolling that back up into the big problem. But other times you have the code and make the little useful tools after the fact. Anyway, I've been talking long enough, so I'm going to stop. But um, hopefully that's helpful. And like I said, it's this stuff is tricky, but I think that the person who wrote this and a lot of other people who are probably watching this, it's keep in mind that you're not failing at what you're learning in the book. This is an algorithmic challenge that um is like this isn't like crazy overwhelming, but it's not nothing. Like this is a real legitimate thing that it takes time to like think it through and figure it out. Like that's normal. And the only way to really wrap your mind around it is to kind of study it. And even if you watch this video and saw what I did, it'll come up again and you're going to have to like figure out stuff similar to this. And so understanding how to like a big part of it is just how do you have the mental patience to just keep working on it even though it feels too big to solve. But also, like, what is a useful, simplified version of this that I could do? Like what if we didn't handle all 8 directions? What if we only handled 4? Or things like, well, what if we just assumed we never went off the board? What if we, like solve the simpler problem first, and then it gets easier to figure out how to grow that into the full solution. But yeah, building these little helpful methods can make a huge difference because now you're solving just a little tiny piece. But also, like, even for the experienced developers, we don't just sit down do these problems and just know the answer and just clickety clack type away, poof, now you got the perfect program. Like we struggle with this stuff too. So you're not alone. And like I said, you do the more of this kind of like I've done enough 2D, grid work like this that it's fairly comfortable territory for me. But I had to struggle with it for a long time too, and I still run into things where I have to stop and think for a while about it. So you're in good company. Don't panic. It's not like you have failed to learn stuff. It's just it's a boss battle for a reason. This is challenging. So yeah, like it's at the same time, like look at what you've done. Like there's a lot here. And anybody who's gotten to this point has like done some pretty cool stuff in C# land. So don't panic. It'll be okay. This is the normal way that writing software goes as you're having to face challenge after challenge. It does get easier. But I don't know that I ever say it gets easy. There will always be new challenges to deal with. And I think that's part of the fun of it is it's never the same old. You never get to a point where things get routine. Or at least it doesn't. I say that and then I'm thinking about it. I know of jobs that I think I'd be bored at because it would become the same old stuff. If you want it to, if you get like, it can get to that point where it's all just the same old stuff over and over again. But there are enough interesting, challenging things out there that if you want things to stay interesting, it's out there. Okay, yeah, I've talked way too long. I thought I'd spend 20 or 30 minutes, and here we are almost an hour. So thanks for watching. We'll see you guys in the next video.